Okay, I'm sorry, just give me a second. I'm just setting something up, and then we begin. Have people started getting acceptances? Have they started sending offer letters? Inshallah. Whatever is good for you, inshallah, will happen. MashaAllah, Meetup Mubarak ho. Congratulations. Is it management science or accounting and finance? ACF. Okay. That's good to hear. Okay, children, let's begin then. MashaAllah. Okay, everyone, let's start then. March 2026, paper 1, variant 2. This is what we're doing today. Please make sure that you're doing the calculations with me and are letting me know the answers. Since the marking scheme is not available for this paper yet, it'll help if you can cross-verify the answers with each other. So that will confirm that we're not making any careless mistakes anywhere. All right, Jalil, let's begin then. March 26, paper 1, variant 1. This is the only component for which we have the paper. All right. So first of all, they're saying the equation of a curve is y equals x cubed minus 3x squared plus 9. What we are looking for is the coordinates of the stationary points of the curve, and we want to find the nature of those stationary points as well. How do you find stationary points? You find the find the derivative, put that equal to 0. That's what we're going to do here. Let's find the derivative dy over dx. What's that going to be? 3x squared minus 6x plus 0. That's the derivative. You put that equal to 0 to find the stationary points. 0 equals 3x squared minus 6x. Take 3x common. That leaves you with x minus 2 inside, which means either x is equal to 0, or you can say first 3x is equal to 0 or x minus 2 is equal to 0. So x is either equal to 0 or x is equal to 2. These are two values of x that we're getting. Now what we do is we put them back in the original equation to find the corresponding y coordinates. Let's see what they turn out to be. Y equals x cubed minus 3x squared plus 9. That's the curve. Input x equal to 0 in this, and that gives you 0 minus 0 plus 9. The y value turns out to be 9, and input that in the other. Input x equal to 2 in this now, and that gives you 2 cube minus 3 into 2 squared plus 9. Simplify this. What does that give you? 5. Okay, so y equals 5. The stationary points that we end up getting from this, they are 0, 9 and 2, 5. These are the stationary points. That is one thing that we were looking for, right? What the stationary points are. Then they're also saying determine the nature of these stationary points. How do you determine the nature of stationary points? You find the second derivative. If that's positive, it's a minimum point. If that's negative, it's a maximum point. Now this is the derivative. Let's find the second derivative and see what that turns out to be. D square y over dx squared. What is this? The first derivative is 3x squared minus 6x. Differentiate that again, and that gives you 6x minus 6. Put x equal to 0 in this, and that gives you d square y over dx square equal to 0 minus 6, which is negative 6. Now, since it's a negative number, that means we have a maximum point. We have a maximum point at 0, 9. 0, 9 is a maximum point. Now, the second thing you do is you input x equal to 2, the other value of x. What does that give you? D square y over dx square, that is equal to 6 into 2 minus 6, and that gives you plus 6. That's a positive number. And what does that tell you? It's a minimum point. There's a minimum point at the point 2, 5. That's what we had to do in the first question. Fairly straightforward, standard differentiation question. Find the first derivative, put that equal to 0 to find the stationary points. The second derivative tells you whether that's minimum or maximum. Make sense to everyone? Any issues with this? Any issues with this? Makes sense, right? Repeat the last part. This first derivative was given as 3x square minus 6x. And that gives us 6x minus 6 as the second derivative. All we are doing after that is we are inputting x equal to 0 in this. The x coordinate of the first stationary point, that turns out to be negative. If the second derivative is negative, that means it's a maximum point. And then we input x equal to 2 in that. That gives us a second derivative of positive 6. If the second derivative is positive, that means it's a minimum point. That's a standard rule that we've got. Is that okay? All right, that was question number 1. Let's look at the next one now. Question number 2 from this paper. It says the diagram shows a triangle ABC with AB equal to 12 centimeters, AB equal to 12 centimeters, AC is equal to 9 centimeters, and angle CAB is 0.8 radians. An arc with center A. A is the center. This is an arc with center A, and radius 9 centimeters is drawn. Inside the triangle, as you can see that there, the shaded region is bounded by this arc, the line segment BC, and part of the line segment AB. All of that is shown in the diagram. All you have to do in the first part is find the perimeter of the shaded region, giving an answer correct to 3 significant figures. How do you find perimeter of a shape? How do you find perimeter of a shape? We want the perimeter of the shaded region. We just find the lengths of each side. That's the boundary of the shape, and we add them up together. These are the 3 sides. One is arc length, one is side BC, and one is side the small length that is left there. What I'll do is I'll call this point something. XB is one side. We know that is just 3 units. Why? Because the radius was 9, so this is 9, and the total length is 12. That means we would have 3 remaining there. So this side is known, XB is 3 units. All we need to find out is, first of all, this arc XC. Let's figure this out. Arc length formula, what's that? S equals R theta. We've got the radius. Radius is 9 units multiplied by the angle 9 into 0.8, and that will give you something. 7.2. That's the arc length. That's one thing that we were looking for. Then we have this side CB. Can we find this side CB as well? We know this side is 12. We know this side is 9. We know the angle in the middle. We need the third side. Cosine rule, right? We know 2 sides and the angle between them. We want the third side. We can use cosine rule. BC squared, that is going to equal 9 squared plus 12 squared minus 2 into 9 into 12 into cos of the angle between those 2 sides, that is 0.8. And that is going to give you the side BC. Let's see what this turns out to be. Has anyone done this? What's this side? 74.511. Okay. 74, is that BC squared or just BC? I think it's BC squared, right? When you take square root of that, that is 8.632. Okay, thank you. 8.632, that's the side BC. Now, what's the perimeter going to be? This side is 3, another is 7.2, another is 8.632. All we have to do is just add up those sides and that will give you the perimeter. The perimeter is equal to 3 plus 7.2 plus 8.632. What's the result that we get? 20.6. That's the perimeter that we were looking for. Okay, that's the second question's first part. Makes sense to everyone? Okay, let me just confirm that as well. 3 plus 7.2 plus 8.632. That's not 20.3, right? Please do, multiple people should be doing the calculation. Yeah, 18.8, yeah. Let me correct that. 18.832, that's what we're getting. Round it off to three significant figures, and that's 18.8. That's the final answer that we get. Okay, all right. Thank you for correcting that. Let's move on. Part B. Find the area of the shaded region. Give your answer correct to three significant figures. That's also pretty straightforward now. What's the area of that shaded region? How do we describe that shaded region? It's triangle minus the sector. Triangle minus the sector. Find the area of this triangle. How do you find that? We've got two sides and the angle between them. Half AB sine C will work. What about the area of the sector? Half r squared theta. And that's going to give you the area of the sector. Half into 9 squared into the angle. Right? So it's triangle minus sector. That will be the area of the shaded region. Let's do that. Area of the triangle. The name of that triangle was ABC minus area of the sector. Okay, now what's the area of the triangle? Half AB sine C. One side was 9, another side was 12 into sine of the angle between them, that is 0.8, minus area of the sector, that's half into 9 squared into theta, which is 0.8, and that will give you a result. You can see what that is. 40.249. That's what you're getting. 40.249 rounded off to three significant figures. Okay, that's the first one. And the second one? Okay, what I'll do is I'll do the calculations myself sat as well. So we can confirm that then. 9 into 12 into sine of 0.8. We need to make sure our calculator is in radian mode. Okay, so the first one is turning out to be 38.737. Okay, 1 over 2. I am really disappointed in your calculator skills right now. Two mistakes in a row. 1 over 2 into 9 squared into 0.8. Okay, so that's 32.4. Subtract these two numbers. You can see what that is. 38.737 minus the answer, and that gives us 6.337. Round it off to three significant figures, and your final answer will be 6.34. That's the final result that we write at the end. Okay, that was question number 2. Again, fairly straightforward. Makes sense, right? Any issues with this? No? Okay, that was question number 2. Let's look at the next one. Question number 3 from this paper. Let's try this. Okay, now they're saying there's a graph. The graph of y equals ax squared plus bx plus c. It has its vertex at 3, negative 5. Vertex means turning point, right? What if you're getting 19.5 there? That will be wrong, of course, Abdullah, if you're getting 19.5. 18.8 was the perimeter. 19.5 is obviously wrong. Why are you getting 19.5? 19.5, yeah. The graph of y equals ax squared plus bx plus c. The turning point is at 3, negative 5. and it intersects the y-axis at 0.31. No, 0 and 31, not 0.31, 0 and 31. Find the values of the constants a, b, and c. Okay, now how do we think about this? We know the vertex, the turning point, and we know the y-intercept. Now, the standard form of this equation is y equals ax squared plus bx plus c. Remember what the c represents? The constant term in the quadratic function, also in the in a linear function. What does c represent? C represents the y-intercept, right? So if we know the y-intercept is 31, we can say the value for c therefore is 31. So this we know this is going to be 31. Okay, so that's one thing that we know. We are also given that the vertex is at 3 and negative 5. Remember the standard completed square form? What does that look like? The standard completed square form? Y equals a into x minus h whole squared plus k. Right? That's the standard completed square form. We also call this vertex form. What we can do is we can input values in this form and then we could compare both of them. That's one way of doing this. Minus b over 2a, you could also do that. That will also work. But since we know this form, the standard completed square form, we could actually write down the function in this form because the value for h is 3 and the value of k is negative 5. Okay, let's input values in this. What do we get from this? We get a, we don't know what the value for a is, but we do know what h is. So it is going to be a into x minus 3 whole squared minus 5. That's another way we could write down that same function. A into x minus 3 whole squared minus 5. So now we know one form of this function is ax squared plus bx plus 31. And the other form that we're getting is this. Let's simplify this a little. This gives us a into x squared minus 6x plus 9 minus 5. Let's simplify this further. Y equals ax squared minus 6ax plus 9a minus 5. These are the same functions. We can compare both of them and that will give us the values of a and b. Let's compare them. What I'll do is I'll write it here parallel to this. So we've got ax squared minus 6ax plus 9a minus 5. Now, if these two are the same equations, the coefficients of x squared should be the same, the coefficients of x should be the same, and the constant term should be the same. We could compare them. We could say 31 should be the same as 9a minus 5, and that gives us one equation. 9a minus 5, that should equal 31. What's the value of a that we get from this? 36 over 9, that is 4. So the value of a is 4. C was 31 that we found earlier. Compare the coefficients of x. What are they going to be? Coefficient of x here is b and the coefficient of x here is minus 6a. Compare both of them and that gives you b equal to negative 6a. Now that you know the value for a already, put that here and you get b equal to negative 6 into 4 and the value of b turns out to be negative 24. That's the value of b that we get. Right, this is how we could find the values of a, b and c. An alternative could be, since you know the turning point, what you could do could be find the turning point of this function, differentiation or minus b over 2a, find the turning point from this function in terms of a and b. Then whatever is the turning point, you equate the x coordinate of that with 3, equate the y coordinate of that with negative 5. You'll get two simultaneous equations, solve them, and you could get the values of a and b from that as well. That's also fine. That'll work equally well. Is that okay? Can we substitute the this coordinate there? Yeah, that could be another idea as well. Slightly lengthier, but you could do that as well. You could input this point in this equation. Input this point in this equation, and that will give you one equation. But the problem is, uh, you would not be able to find all values from that because you only get two equations, right? One equation from this point, one equation from this point, you would be able to find the value of C, yes, but you would just have one equation and two unknowns then. So we do need to use the idea that this is the turning point as well, right? That will not be sufficient. Okay. Acha, chalo, let me show you how to do it using the other method as well quickly. Let me quickly show that as well. Let's do that quickly as well. Acha. So if you do not want to use the vertex form, the alternative could be, we know the value of C is obvious, right? So we know the value of C is 31. So this we already know. So the function becomes y equals ax squared plus bx plus 31. The turning point that we're given, that is 3 and negative 5. So we know that the turning point of this function is 3 and negative 5. What we could do could be, we could find the turning point of this equation as well. Okay, let's find that. Turning point from this equation, we could use minus b over 2a because since it's a quadratic function, we could use differentiation as well. Let's see what the turning point turns out to be in terms of a and b. Find the derivative. That will give us 2ax plus b. Put this equal to 0. 0 equals 2ax plus b. The value of x turns out to be minus b over 2a. Right? So if you remember the formula, you could just use that directly as well. Okay, now this is the x coordinate. This should equal 3. Okay? That gives you one equation. You input this value back in the function, and that will give you the corresponding y coordinate. Let's see what that turns out to be. If I were to input this value there now, you get y equals a into minus b over 2a whole squared plus b into minus b over 2a plus 31. Okay? Now that's the y coordinate. Now, since we know that the x coordinate is 3, we could equate this to 3 and we get one equation from this. Minus b equals 6 times a, or b equals negative 6 times a. That's one equation. Y coordinate is supposed to equal negative 5. So we equate this to negative 5 and this gives us another equation. Simplify this. You get b squared divided by 4 times a. 1a will get cancelled in the denominator. This is what we get. Minus b squared over 2a plus 31 plus 36. This equal plus 31 plus 5, that gives you 36. That's another equation that we're getting. Now you could input b equal to negative 6a here, solve that equation. You can do this afterwards, right? You just have to solve simultaneous equations. You'll get a value of a from this, put that back here. You'll get the corresponding value of b from that as well. Okay, that's slightly longer, but you could do it this way as well. Makes sense, right? Okay, let's move on. Let's move on to the next one. Now they're saying the graph is translated by this vector. Find the equation of the translated graph. How do we think about this? We know the function. We know the values of a, b, and c now, right? The function was y equals ax squared plus bx plus c. Something wrong with my undo button. Ax squared plus bx plus c. We know the value for a is negative 20. A is 4, b is negative 24. 4x squared minus 24x plus 31. That's the function that we've got, okay? We need to translate it by minus 27. What does that mean? In function notation, that would be that we are adding 7 outside the function because it's 7 units up. So we add 7 outside the function. Inside the function, we've got negative 2. As in the translation vector has negative 2x component. That means we're going 2 units left. In function notation, 2 units left means plus 2, right? In horizontal transformations, it works the other way around. So it'll be f of x plus 2 whole plus 7. Now just apply that transformation here. In place of x, you put x plus 2, so it becomes 4 into x plus 2 whole squared minus 24 into x plus 2 plus 31. And then outside this whole function, you have a plus 7. So you have plus 7 outside, and that's the function that you needed. Now they have not really specified that you need to simplify this. So as long as you just add this up and write 38, it would not be necessary to expand this further. So you could write it like this: 4 into x plus 2 whole squared minus 24 into x plus 2 plus 38, and that will be sufficient. You'll get those 2 marks. But to be on the safer side, you could expand it as well, and that will give you x squared plus 4x plus 4 minus 24x minus 48 plus 38. Simplify this, and that gives you 4x squared plus 16x plus 16 minus 24x minus 48 plus 38. And you can see what that turns out to be: 4x squared. Can somebody add the x terms? We only have 2 x terms. That will give us minus 8x. And the constants: 16 minus 48 plus 38, that will just turn out to be 6, right? Yeah, that's the function. Now, this is one way of doing this. Another idea could be you could use the completed square form, this form as well. That would also work. You can do it using that as well. Okay. Yes, you can definitely do it using the completed square form as well. Is it necessary to do it that way? Not really. Completing the square for quadratic functions is necessary if you are trying to figure out what transformations are happening. If you need to determine what transformations are happening, then you would not be generally not be able to do that unless you first complete the square. But if the transformation is already given and you just have to apply that, then it doesn't matter. You can apply that on the expanded form, on the standard form, or the completed square form. It works in both of them. When you have to identify transformations for quadratic functions, in that case, it's a good idea to use the completed square form, because that makes it easier to spot what the transformations are. Makes sense, right? Okay. That was question number 3. Let's move on to the next one. Question number 4 from this paper. Acha. It says the function f is defined by this: f of x equals 2x plus 3 over x minus 3 for x less than 3. Okay, that's a function. Find an expression for f inverse of x. That's straightforward. We start like this. We can say let y equals f of x. Let y equals f of x, and that gives us y equal to 2x plus 1 over x minus 3. Multiply x minus 3 on the other side, and that simplifies to xy minus 3y equals 2x plus 1. Make x the subject, take all x terms to one side, xy minus 2x, that equals 3y plus 1. Take x common, that leaves us with y minus 2 inside, that equals 3y plus 1. And then x equals 3y plus 1 divided by y minus 2. Write it in the inverse form now. Replace x with f inverse of x on the right side. Make sure that you change the variable to x, 3x plus 1 divided by x minus 2. That's an expression that we wanted to find f inverse of x. Is it necessary to mention this statement first? It's a good idea. You should do that. It's good practice. But even if you don't do it, you don't generally lose marks because of that. But I would advise that you still do it, so the examiner knows what you're doing. You're saying y, you're assuming y to be equal to y, f of x. So you should do that. Achha. Now they're saying, given that f of x is equal to this, find the possible values of the integers p, q, r, and s. Possible values. Okay, that's interesting. Why are they saying possible values? Let's think about it. F of x, that is equal to 2x plus 3 divided by x minus 3. Okay, all right. So I understand why they're saying possible values now. 2x plus 3 over x minus 3. Achha, f of x equals 2x plus 3 over x minus 3. How do you find f of x? You input this function inside this same function. So it will become, if you want to find f of x, you're inputting f inside f. That becomes f of 2x plus 3 divided by x minus 3. Okay, now in this function, wherever you've got x, you have to input, is that 2x plus 1? That's 2x plus 1. Yeah, okay, I copied that wrong. This is 2x plus 1. 2x plus 1 over x minus 3, that's the function. We need to input this inside f, okay? You get 2 into 2x plus 1 divided by x minus 3 plus 1 outside, whole divided by 2x plus 1 over x minus 3 minus 3. Now, those of you who get confused with expressions like these where you have fractions inside a fraction, you could write it separately as well, like this: 2 into 2x plus 1 over x minus 3 plus 1 divided by 2x plus 1 over x minus 3 minus 3. Then take LCM and switch the numerator and denominator to make it multiplication. So if you find it easier that way, you could do that, if that helps you avoid any careless errors. You can do it directly as well. If we do that directly, what we do now is we take LCM both here and in the denominator. Let's take LCM. When we take LCM, the LCM is going to be x minus 3, right? That's the only denominator that we've got. So x minus 3, that's the LCM. That gives us 2 into 2x plus 1, which is 4x plus 2, x minus 3 into 1, that will give us plus x minus 3. Take LCM in the denominator as well, that's x minus 3 as well. And we are left with 2x plus 1 minus 3 into x minus 3. Okay. Again, if this confuses you, write it separately. But just make sure that you're not making any careless mistakes there. Okay, now you see x minus 3 is the denominator both above and below. So that gets eliminated, right? X minus 3 and x minus 3, they get cancelled. What are we left with? In the numerator, we've got 5x minus 1. And in the denominator, 2x plus 1 minus 3x plus 9. And that simplifies further to 5x minus 1. What form did they want? Px plus q. And in the denominator, they have the constant first. Let's write the constant first. 9 plus 1, which is 10 minus x. That is f of x. Now, they told us in the question that f of x is px plus q divided by r plus sx. We needed to find the possible values of integers p, q, r, and s. What are the values of p, q, r, and s? We could say, comparing both of them, p is equal to 5, q is equal to -1, r is equal to 10, and s is equal to -1. These are the values that we end up getting for this. Make sense? Any issues with this? Do you guys understand why they're saying possible values? Because generally when they say possible values, it means there could be multiple possible answers, right? But we are not getting multiple possible answers. Why did they mention that? Just to confuse you? No, generally in Cambridge they don't do that. They do that in SAT, but not in Cambridge exams. There is a reason why they said possible values. Does anyone understand that? No, they're not. The reason is it's a fraction, right? So this fraction is equivalent to, for example, 10x minus 2. If I were to multiply the numerator and denominator by 2, 10x minus 2 over 20 minus 2x. These two fractions are equivalent, right? I've just multiplied the numerator and denominator by 2. So in this case, if I end up getting this fraction, I could say P is equal to 10, Q is equal to -2, and R is equal to 20, and S is equal to -2, and that will also be an acceptable answer. That's also an acceptable answer. So if you write any acceptable answer, that will be correct. So no, they're not trying to flaunt their English. No, they're not trying to do that. Uh, there are infinitely many possible values of P, Q, R, and S. So in case somebody overthinks in the exam that, okay, which one do they write? You should know that any of them is going to be correct. That is why they mentioned that there. Okay. Makes sense, right? Let's move on. That was part 4. Question number 4. There's no other part. Okay, question number 5. Now we need to prove this identity. Question number 5. How would they potentially get any other answer than the ones that we got? I just told you. In this case, while simplifying, if they ended up, having some multiple of this fraction, then that would also be acceptable. That's all they're saying. Okay. All right. Prove this identity. That's the next question that we've got. 1 over 1 minus sine theta plus 1 over 1 plus sine theta. That is identical to 2 over cos square theta. That's what you want to prove. Now let's start from the left-hand side because we've got multiple fractions on the left side. It will be easier to simplify them to this single fraction. Okay. Let's simplify the left-hand side. Take LCM. You get 1 minus sine theta into 1 plus sine theta in the denominator. Multiply this there, and that gives you 1 plus sine theta plus 1 minus sine theta. Okay, now simplify this further. In the numerator, we just have 2. In the denominator, this is a minus b into a plus b. That's a square minus b square. It will become 1 minus sine square theta. And then that is cos square theta. That's all that they wanted. Okay. 2 over cos square theta. And that is the same thing as the right-hand side. Okay, that's the identity proved. You can start from any side, doesn't matter. You could simplify, you could convert the right side to the left side somehow as well, although that will be much more complicated. But if you want to do that, you can do that. Are you sure you did it that way? Because you would have to use partial fractions for that. If you write it like this, 2 over 1 minus sine square theta, and then you could say, okay, a square minus b squared is a plus b into a minus b, 2 over 1 plus sine theta, and 1 minus sine theta. How would you break it down now? Abdullah, you're just joking, right? Because how do you go from this to this now? You'll have to find partial fractions, right? That's pretty complicated. So no. In this case, it would not be a good idea to do that. But in general, you can start from any direction, from any side, prove that equal to the other side, and that will work. Okay? Achha. That was part A. Now they're saying hence solve this equation. Now, is it related to the previous part? In the previous part on the left side, we had this expression. In the equation that they've given, we've got this expression. What's the difference between the two? It has been multiplied by 3. The numerator is multiplied by 3 here. Okay. So if we multiply by 3 on the left side on this identity, the right side would also be multiplied by 3. So we get 2 into 3, that is 6 over cos square theta. So this equation that we have got, we could write it as 6 over cos square theta equal to 12. Right? The left hand side, we could replace with 6 over cos square theta. And now we can solve this equation. Cos square theta goes to the other side. Cos square theta, that is equal to 1 over 2. Take square root on both sides. And that gives you cos theta equal to plus minus square root of 1 over 2. Do not forget plus minus. Whenever we take square root, we have plus minus. Now find the basic angle. Cos alpha equals square root of 1 over 2. What's the basic angle that we get? In degrees, is it 45? Under root 2 over 2, I think it is 45. Yeah, 45. Basic angle is 45. Basic angle is 45. Now, which quadrants can we be in? We can be in any 4 quadrants. All 4 quadrants are possible. So this, or this. You write down the possible answers in all 4 quadrants from 0 to 360. This could be alpha, this could be alpha, this could be alpha, and this could be alpha. In the first quadrant, it will be 45. In the second quadrant, it will be 180 minus 45, which is 135. In the third quadrant, it will be 180 plus 35, which will be 225. And in the fourth quadrant, it will be 360 minus 45, and that will be 315. These are 4 possible answers that we get for this equation. Makes sense, right? Really straightforward, this one as well. Yeah, this looks like an easier paper until now. This does look like an easy paper. Until now, at least. Let's see what's coming. All right, Chennai, let's move on. That was question number 5. The next one is question number 6. Equation of a circle is this: x square plus y square, that is equal to 45 over 4. State the center and radius of the circle. What's the standard form of the equation of a circle? It's x minus a whole squared plus y minus b whole squared equals r squared. Now this is just x squared. That means x minus 0 whole squared. And this is y minus 0 whole squared. So the center is just 0, 0. Okay. What about the radius? What's the radius? Square root of 45 over 4. And that will give you the result. Okay. Square root of 45 over 4. The denominator, in fact, the numerator as well, if you put this on a calculator, your calculator is going to simplify this for you. Square root of 45 over 4, it simplifies to 3 under root 5 over 2. Okay, you just write it like this. That's the radius. Okay, that's the first part, fairly straightforward. Now they're saying this line intersects the circle at the points A and B. Find the exact distance AB. Okay, that's also a relatively easier question. We know the equation of the circle, which is x squared plus y squared equal to 45 over 4. That's the equation of the circle. Then there's a line, x plus y equal to 3 over 2. We want to find the points of intersection of this line and the circle. How do we do that? We solve them simultaneously. Make y the subject. Make y the subject in this linear equation and put that in the other equation. See what that gives you. Y equals 3 over 2 minus x. Put that in the other equation. No, do not try to make x or y the subject from the circle equation, because when you take square root, you would have to have plus minus there. That is going to complicate things. So it's not a good idea that you make x or y the subject from the circles equation. Make it from the lines equation, because you don't have any square roots problem there. Let's input this here. That gives us x squared plus y squared. That will be 3 over 2 minus x whole squared equals 45 over 4. That's a quadratic equation. Let's simplify this. A minus b whole squared. That will be a squared, which is 9 over 4 minus 2ab. 2 into 3 over 2, that's 3. 3 into x, that is 3x plus b squared, which is x squared. This is equal to 45 over 4. Now to simplify this, I'll just multiply the whole equation by 4, the LCM, so that the fractions get eliminated. If I multiply the whole equation by 4, I get 4x squared plus 9 minus 12x plus 4x squared equal to 45. Okay, on the left side now we've got 8x squared minus 12x minus 36 equal to 0. That's an equation that we're getting. It's a quadratic equation. Solve this and see what that gives you. We could first simplify this a little, divide by 4, and it will become 2x squared minus 3x minus 9 equal to 0. Can we factorize this? 18, 18, 6 and 3 would work, right? 6 and 3, 2x squared minus 6x plus 3x minus 9 equal to 0. We get two factors from this, 2x plus 3 and x minus 3. These are the two factors that we end up getting from this. One possible value of x is negative 3 over 2 and the other possible value of x is 3. Yeah, if you don't want to factorize, just put in the quadratic formula and you'll get the results. That's also fine. But you need to make sure that you show you're working either this factorization step or the step in which you are inputting values in the quadratic formula. That is necessary. Okay. All right. We've got the x values. Put them in the other equation now and see what that gives you. If you input x equal to negative 3 over 2 in this, see what you get from that, and then you input x equal to 3 in this. Now, negative 3 over 2, that will give you y equal to 3 over 2 minus 3 over 2. That's 3, right? Put x equal to 3, and that gives you 3 over 2 minus 3, which is minus 3 over 2. So the 2 points that we get, they are minus 3 over 2, 3, and 3 and minus 3 over 2. That's the final result that we get. Any issues with this? That was 6 marks. This is all that we had to do. Again, extremely straightforward. March papers are often relatively more difficult because they are specific to India, and Indians are good at maths. They generally have slightly more difficult papers. Acha, we need to find distance too. Okay, let's find that. Let's find that. We've got the points. We've got the points. Now we need to find the distance. Let's find the distance. Distance AB. We can call any of those points A, the other B. We can find the distance. X2 minus x1 whole squared. We can say 3 minus 3 over 2. That will become 3 plus 3 over 2 whole squared plus y2 minus y1 minus 3 over 2 minus 3 whole squared. Now, they want an exact answer. Whenever they want an exact answer, it's necessary to show working. So do not write down the final answer directly. Show working for that. Now, what does this turn out to be? This will be 9 over 2, right? 9 over 2 squared, that will be 81 over 4. And the other one is also going to be 81 over 4. One 62 divided by 4 and then square root of that. Now, you can put this on a calculator. Square root of 162 divided by 4. That is 9 under root 2 divided by 2. That's your final answer. That's what we were looking for. Make sense, right? Any issues with this? Okay, that was question number 6. There's Azan going on here. We'll have a 1 minute break and then we'll resume, inshallah. Okay? Just 1 minute. Okay, children, let's resume. Pakistan and Zambia are brothers. Why not sisters, Musa? Why did you assume the gender? Countries, isn't that? Question number 7. Question number 7. The equation of a curve C is such that the equation of a curve C is such that dy by dx is equal to this. The curve passes through the point 4, 7. Find y in terms of x. How do we do that? We've got the derivative given. We've got the derivative given. We need to find the equation of the curve. We integrate, right? And then input this point. Let's do that. Y equals. Now, first we should write it in a proper form. Okay, this question actually is a bit tricky. You need some thinking for this. Dy by dx equals x minus 3 whole squared. Let's bring this to the numerator. And that will become x power negative 1 over 2, right? In the denominator, this means x power 1 over 2. When you bring that to the numerator, it becomes x power negative 1 over 2. Now it's a product. This is a product. Now, if you knew paper 3, you could use the product rule of differentiation and that will work. But if you do not know product rule of differentiation, how would you differentiate it? You would first need to simplify this, right? You'll first need to simplify this. You need to expand this thing. X minus 3 whole squared. You expand it first of all. It becomes x squared minus 6x plus 9. That multiplied by x power negative 1 over 2. Now you simplify this further. X power 2. We are not differentiating. We are given the derivative already, right? We're just simplifying that. We have not found the derivative. The derivative was already given. Okay. Achha. Dy over dx is equal to this. Why is expanding necessary? Okay, sorry, we have to integrate. So I'm sorry about that. We have to integrate. So for integration, we have to integrate. For integration as well, we cannot integrate products directly, right? It's a product. We don't know how to integrate products in paper 1, right? We do that in paper 3, although this will be hard to do using integration by parts as well. But we cannot integrate it directly, right? Because it's a product. So for that reason, we need to expand it. Okay. Acha. Now, x squared into x power negative 1 over 2, what is that going to give you? X power 3 over 2 minus 6x, x power 1 and x power negative 1 over 2, that becomes x power 1 over 2 plus 9x power negative 1 over 2. Now, that's the derivative that is given. Now, we are looking for the equation of the curve. For that, we just integrate it now. Y equals x power 5 over 2, 3 over 2 plus 1, that's 5 over 2, divide by the new power, minus 6 as it is, into x raised to power 3 over 2, divided by 3 over 2, plus 9 into x power 1 over 2, divided by 1 over 2. But whenever we integrate, we always have plus c as well, right? So we have plus c there. Now, simplify this a little. Take 2 to the numerator, and that will become 2x raised to power 5 over 2 divided by 5 minus 12 over 3. Let's cancel it out. This gives you 2, and then this 2 goes to the numerator, and that gives you 4. So you've got 4x power 3 over 2. This 2 goes to the numerator, and we get plus 18x power 1 over 2 plus c. This is what the function turns out to be. Okay? All right, now this is the point that we're given. Input that point, find the value of c. The point is 4 and 7, right? Let's input that. 7 equals 2 into 4 raised to power 5 over 2 divided by 5 minus 4 into 4 raised to power 3 over 2 plus 18 into 4 raised to power 1 over 2 plus c. And you can see what the value of c turns out to be from this. We generally try to avoid decimals as much as possible in equations, okay? So ideally, we want an exact value for this. Put this whole thing on your calculator, see if you're getting an exact value. If you get that directly, that will be great. Otherwise, you have to simplify this manually a bit. Okay, we are getting the exact value. All right, good. Negative 49 over 5. That's the value of C that we're getting. Okay. Mechanics paper is not available for now. Mechanics paper is not available for now. I tried searching for that, but I could not find that yet. Other March papers, we don't have that yet, okay? Okay, chale. C is equal to negative 49 over 5. That's the value of C that we're getting. Now, put that back and that will give you the result. Y is equal to 2x power 5 over 2 divided by 5 minus 4x raised to power 3 over 2, 18x power 1 over 2 minus 49 over 5. Okay? Any issues with this? Treat सिर्फ A star पे है, बिल्कुल treat सिर्फ A star पे है, but you can come to meet me on A as well, or any grade actually, but treat सिर्फ A star पे, yes. Yeah, you पे you cannot come to meet as well. I'll not like to meet you until next year after you improve that grade. मूसा बेटा हर किसी ये क्यों पूछना होता है आपने? Why do you have to flaunt or flex your own English score? That's whatever you want to say. Is this a Bible method you want P3 ever get? Okay, so we've got someone who got a better score than you, Musa. Okay, so in general, if you use any method that is not part of your syllabus, as long as it is correct, it is allowed. As long as it is correct, it is allowed. Okay. So in paper one, if you want to use a P3 method, it's perfectly okay. There's nothing wrong with that. As long as you're showing working for that, it is allowed. If you want to use some further math method somewhere, that's also fine. Or anything else that you've learned, as long as it's logical and you're showing your working, you're allowed to do that. Okay. All right. अच्छा, let's move on. अच्छा, ये पेपर लीक वाली बातें जो भी करेंगे, I will actually remove you from class. I don't want to hear that, okay? I'll get rid of this. Okay. Acha, that's the function that we're getting. Any issues with this? Okay, chale. Now they're saying equation of a different curve D is also such that dy over dx is equal to this. That's a different curve now. This curve instead passes through the point 4k. Describe in terms of k the transformation that maps the curve C onto curve D. Okay, how do we think about this now? The transformation that maps the curve C onto D. Okay, that's interesting. So in the first part, we had the derivative dy over dx that was equal to x minus 3 whole squared. Or in the first part, we had x minus 3 whole squared divided by square root of x. This is also the same. Acha, it's the same derivative. All right. So the derivative is the same. We had the same derivative in the first part. It's not different. I thought it's also different. Derivative is the same for the first curve as well. The only thing that has changed now is this point. Okay. Acha. Now, how is that point going to affect your final curve? Let's think about that. The curve is still the same. Y equals, as in most of the curve is still the same. It's still 2x power 5 over 2 over 5 minus 4 into x power 3 over 2 plus 18 x power 1 over 2 plus c. That's the equation of the curve. Now think about it. If you were to input this point in this now, 4k, let's input this point, put 4k inside this. It's the same x coordinate as well. In the previous case as well, it was the same x coordinate, only the y coordinate was different. So earlier we did this. We put we put the point as 4, 7, right? That was what we did earlier. We put 4 and 7. See what the difference in both of these is going to be. See the difference? I'll just copy that here so I don't have to write that whole thing again. When you input x equal to 4, in this new equation, you would have k on the other side. In that previous equation, we had 7 on the other side. How will the value of c be different? How will the value of c be different? In the first case, in the previous part, we were getting negative 49 over 5. What happens in this case? What's the value of k going to be? What's the value of c going to be in this case? Can you evaluate this? What's the value of c that you get? Take everything to the other side. Can somebody tell me what this result is? Okay, can multiple people please do this? Okay. No decimal answers, please. No decimal answers. Okay, I'll do that as well. 2 into 4 raised to power 5 over 2, that's 2.5 divided by 5. Minus 4 into 4 raised to power 1.5 plus 18 into 4 raised to power 1 over 2, which is again just 2. This is what this value is, right? When it goes to the other side, it will become k minus 84 over 5. That's the value that we're getting now. Okay, this is how it is changing. So the constant term earlier was negative 49 over 5. Now that constant term is this. What's the difference between them? That will be this number that we had there, 7. That will be the difference between the two. Let's figure that out. Let's evaluate it. It will be, this was the previous case, this is the new case. Let's subtract from k minus 84 over 5. Let's subtract from this later number, the previous number, which was minus 49 over 5. What do we get from this? Minus 84 over 5 plus 49 over 5. What's that? That is negative 7. So we get k minus 7 from this. K minus 7. What does that mean? Whatever was the original curve, whatever was the curve before, now what happens is it is going up by k minus 7 units. That's the difference between the constants. Okay? Whatever was the curve before, now it is k minus 7 units above. So it's going to be a translation 0 k minus 7. Writing down this vector is important. Okay. Now, this is one way of doing this. I'm just thinking, since they're talking about the same x coordinate, you're right. Since they're talking about the same x coordinate, it's that same point that we had before, and it has just moved by some distance. So we could actually just do it directly as well in a way. Yeah, let's do it directly as well. So this is one way to figure this out. Let's actually do it another way as well, which will probably be easier if you understand the logic. It's the same derivative as before. This is also the same derivative. Both the curves have the same gradients. Both of them have the same gradient, right? If they have the same gradient, whatever the shape of the curve is, that is the same for both of them, no matter what the shape is. So let's just draw a random curve. This curve was of this form, right? X power 5 over 2. Now we don't know what this function looks like. Whatever the curve is, let's say it's maybe, I don't know, something like this, right? In some part, or maybe something like this. Then the new curve that we've got now, that has the same gradient. So it will be exactly of the same shape because the gradient is the same. So let's say it looks like this. Now there is some point on the original curve that they're saying has an x coordinate of 4 and 7. On the original curve, there was some curve that has, there was some point that has coordinates of 4, 7. Now this other curve, This has a point where the x coordinate is the same, so it will be exactly on the same vertical line. It could be above or below, doesn't matter. But the point is, it has coordinates 4 and k. So what kind of transformation is that? That's a vertical translation. That's a vertical translation. By how much? Just find the difference between these 2 points. How much is the vertical difference between these 2 points? This is k, this is 7. The difference is k minus 7. That's it. For example, if this number was 20, let's say, then what will be the difference? 20 minus 7, it will be 13 units above that. Now, in this case, this is k. We could say that's k minus 7. So the transformation that we've got, therefore, is going to be a translation, and we have to write down the vector for that. That will be 0 and k minus 7. That's the translation vector that we've got this. Is that all right? Okay, that's a good point. How do we know? How do we know that k is larger than 7? We don't know that necessarily. K could be smaller than 7 as well. Let's see what happens in that case. Okay, let's see what happens in that case. If k was smaller. If k was smaller, the other curve would have been like this, right? What I'll do is I'll just copy that same curve as before, so we have exactly the same shape. If you say the curve was below this, what happens in that case? This is the original one. I'll just highlight the original one. The original curve is this. Okay. Now, what if this transformed curve was below? We would say that's 4 and k. You are saying the transformation would be 7 minus k then? That would be incorrect. That will still be k minus 7. The problem is, if k was a smaller number, let's say k was, so if this other curve is below that, then that necessarily means that k is a smaller number than 7, right? K will be a smaller number. Now, if k is a smaller number, let's say it's 3, for instance. Now, if the value of k was 3, if you do 7 minus k, then 7 minus 3 is going to be 4. It's a positive number, and that positive number tells you that it would be actually moving in the upwards direction. So that will be a contradiction. Okay, so in either case, it would be k minus 7. Even if it's going below, we would still say the transformation, the vertical component is going to be k minus 7, because if this was 3, for instance, then 3 minus 7, that gives you negative 4, and that would be the correct transformation in that case. So whether that second curve is below or above, whether the second curve is below or above, you get the same vector at the end. That's k minus 7. Okay? Is that all right? Yeah, so we do not know that k is necessarily greater, but in the other case as well, we get the same thing. Achha, now let me re-explain the other method as well, which is longer, but you could do it that way as well. So that was, you have the derivative given. We already integrated this earlier as well. In the first part, we have already done this work. So basically, we have done this work already. What I'll do is I'll write it on the, or let's do it this way. This part we are done with already in part A. Okay. In the second part, they gave us another point 4k. We said, if the curve passes through this point, let's find the equation of the curve in this form as well. The equation of the form, the equation of the curve ends up having this c value in the second case. So now, in the first case, the constant was negative 49 over 5, or in the original curve. In this transformed curve, the constant is this. k minus 85, 84 over 5. The constant outside, if this was f of x, this would be f of x plus something. You're adding something outside the whole thing. Now, how much are you adding outside? That is what we want to find out. That how much would you need to add to negative 49 over 5 to get to k minus 80, 84 over 5? Again, let's take some numbers. That makes it easier to understand. Let's suppose the original c was 5. And after transformation, the c was 16. How much do you need to add to 5 to get to 16? You need to add 11. How do you get 11? 16 minus 5. That's exactly what we're doing here. We're trying to see how do you get from negative 49 over 5 to k minus 84 over 5. How do you get that number? K minus 84 over 5 minus 49 over 5. And that gives you that number that you need to add outside to get to that second curve. So that is why the translation vector becomes this. Is that okay? All right. Now this was a bit tricky, this part B. That was question number 7. Let's move on to the next one now. We don't have the other papers, unfortunately. We don't have the other papers yet. As I told in the beginning, there is a P3 going around as well, but that looks like something that somebody has just typed out from memory. So we're not sure how reliable that is, but we don't have the actual paper. And for M1 and S1, we don't know anything. We don't have any questions at all for them. Hopefully, we'll have them in a week or so, and we will do them when they are out, inshallah. Now they're saying find the complete expansion of this 3 minus 2x whole raised to power 4. That's just binomial expansion. The formula is a plus b whole raised to power n, that is equal to a power n plus nc1 into a raised to power n minus 1 times b plus nc2 into a raised to power n minus 2b squared, and so on it continues until b raised to power n. Now they're saying complete expansion. Okay, so how do we do that? We can say a is 3, b is negative 2x, and the power is 4, n is 4. Let's input values in the formula. 3 minus 2x power 4, that equals 3 raised to power 4 plus 4c1 into 3 raised to power 4 minus 1, which is 3, into minus 2x plus 4c2 into 3 raised to power 2 into minus 2x whole squared plus 4c3 into 3 power 1 into minus 2x power 3 plus 4c4 into 3 raised to power 0 into minus 2x whole raised to power 4. Can we go any further? 4c5, that'll be undefined. We stop at the point where the number above c and below c, they become the same. When they become the same, we stop at that point. That's the last term. Now just simplify this. 3 power 4 is 81. 4c1 is 4. 3 cube is 27 into minus 2x. 4c2, put this on your calculator, you'll get 6 for this. 3 squared is 9. Minus 2 squared is 4. 4x squared. 4c3 is 4 into 3 into minus 8x cube plus 1 into 1 into 16x raised to power 4. Now, let's simplify this. 81 minus, what's this? 108 into 2, that will be 216, right? Can somebody please confirm this as well? 2166, and then the next one, 6 into 9 is 54. 54 into 4, that's also 216. 216x squared minus 12 times 8, that's 96x cube, and then 16x raised to power 4. That's the complete expansion that we're looking for. Okay. Yeah, the other papers were freely available last year. I think they came out before 15th of April last year, but this year we don't have them yet. Okay, part A. That was part A. Let's look at part B now. Use your answer to part A to find 3 minus 2 under root 2 whole raised to power 4. Give an answer in this form where P and Q are integers to be found. Okay. Uh, how do we use the previous answer? In the first part, we proved that 3 minus 2x whole raised to power 4 is equal to this. Now the question says use your answer to part A. If you evaluate this on your calculator without using the first part, you don't get marks for that. Okay? You cannot do it directly. You have to use the previous part for this. Now compare it with the previous part. What's the difference? 3 minus 2 under root 2 whole raised to power 4. The only difference is in place of x, we've got under root 2 here. Right? So the value of x is under root 2. So what we do is, on the right side, wherever we've got x, we replace that with under root 2. So it becomes 81 minus 216 under root 2. You need to show this working. Into plus 216 into under root 2 whole squared minus 96 into under root 2 whole cube plus 16 into under root 2 whole raised to power 4. Now you can simplify this. 81 minus 216 under root 2. Under root 2 and square, they get cancelled. 216 times 2, that will give you 432. This you can put on your calculator. Your calculator is going to give you something in terms of under root 2 for this. Just put this on a calculator like this. 96 into under root 2 whole cube. Okay. And that does not give you this. Okay, that's not very good. Let me try this if that helps. 2 raised to power 3 over 2. Let's see if the calculator, no, 1 over 2. Okay, calculator is still not helping. What if we do 3 over 2 directly? Okay, so that's unfortunate. Okay, calculator is not giving us this result, so we'll have to do some manual work. Okay, we'll have to do some manual work. Is anyone's calculator giving it? Because my calculator is not giving it. It works in direct mode. What do you mean by that? I actually learned what you mean by that. Okay, switch from radian. In degree mode, you mean? I don't know. Why would that have anything to do with it? Let's just try 96 under root 2. We can do it manually as well, but I just want to try if this works. No, that does not have anything to do with it, right? It works for you? Okay. So it works on some calculators and my calculator is not working. Okay. So if it doesn't work on your calculator for some reason, what you do is you can do it like this. You can say, this is under root 2. Under root 2 can be written as 2 raised to power 1 over 2 power 3, right? Or you could say 2 raised to power 3 over 2. Okay, you can write it like this. Okay. What about the next one? 2 raised to power 1 over 2 into 4, and that will be 2 raised to power 2. Okay. Now you could break this 2 power 3 over 2 like this. I'll just do it on the side and then write down the result directly. 96 into 2 raised to power 3 over 2. We could break it like this. 2 power 1 into 2 power 1 over 2. And now 96 and 2 can multiply with each other and that will give us 192. And 2 power 1 over 2 that we can write as under root 2. So that's what we can do here. We can say 81 minus 216 under root 2 plus 432 minus 192 under root 2 plus 16 times 4. That is 64. Okay, now you can add the numbers. 81 plus 432 plus 64. That's 577. And then the under root 2 terms, negative 216 and negative 192. And that's giving me minus 408 times under root 2. That's the result that we end up getting. Is that okay to everyone? Any issues? So if your calculator cannot do that for you, then this is what you would do. Let me just try this separately. Under root 2 whole raised to power 3 over 2. So, sorry, power was 3 there, not 3 over 2. Okay, that is giving us this result. All right. Okay. So if you want to do it using a calculator, then rather than inputting 96, because that then makes the calculator refuse to give you the exact answer. All right. So how would you do this on your calculator then? Because I don't really expect many people to be able to do this in the exam. You will end up making careless mistakes. So do it like this then. On your calculator, do not put this whole thing directly. Do not put this whole thing directly. Just input the square root part on your calculator. Under root 2 whole power 3. Put this on your calculator. And that will simplify it to 2 under root 2 for you. Once you're done with that, now you multiply 96 and 2, and then you can simplify that further. Okay? It's happening a lot in recent P3 papers as well. Like one of the questions that we were doing just yesterday, it had that awful expression that we ended up spending quite some time on this extremely complicated paper with a threshold of 45 out of 75 for an A. We had too many square roots there, right? To simplify this as well, we did not do this yesterday, but that will make it much simpler now, right? So input each of them separately. Do not put the whole thing on a calculator. Input under root 30 separately, input under root 50 separately. All the square input under root 5610 separately. And that will help the calculator simplify this for you a bit better, or maybe not, because it's not working on 5610. This does not simplify at all. Under root 50, does that simplify? Okay, this is working, but the bigger number 95610, that is not working. Okay, we'll see. What if I were to multiply this by 50, 5610 into 50? Does the calculator help here? It does not. Okay, so with larger numbers, it still refuses to work. Okay, anyway, let's go back there. Let's go back. Acha, so those of you who have this working on your calculators, which one do you have? The white version? ClassWiz? Is it working for you guys? All right, good. Yeah, that's a good point, Visse. So there's a comment, if you cannot even do this yourself, the you should not be in A-levels. Granted, but unfortunately, over the last many years, I have learned not to expect too much from A-level students as well. Okay. X power 2 over 3 plus 8x whole raised to power 1 over 3 equal to 24. How do we do this now? This is disguised quadratic, right? We can use a substitution to simplify this. 8x raised to power 2 over 3 plus 8 power 1 over 3 into x power 1 over 3 equals 24. And we get x power 2 over 3 plus 2x raised to power 1 over 3 equal to 24. One power is 2 times the other. One power is 2 times the other. So we could just substitute the smaller power with another letter. So u equals x power 1 over 3, for instance. And that will give you u squared plus 2u equal to 24. Khadija, I'll go back after this question. Just give me a couple of minutes. u squared plus 20, u squared plus 2u minus 24 equal to 0. Can we factorize this? Can we factorize this? 24, 6, 4, 6, 4 work. U squared plus 6u minus 4u minus 24 equal to 0. Okay, now u plus 6 into u minus 4. These are the two factors that we end up getting from this, which means u is either equal to negative 6 or u is equal to 4. Okay, now x power 1 over 3 equals negative 6 or x power 1 over 3 equals 4. Take cube on both sides. On the left side, we get x equal to negative 216. For the other one, we get x equal to 64. Now, there are two answers that we're getting. Are both of them possible? Whenever you get multiple answers, you should look at the equation again and see if both of them are possible. Could there be a problem because of any of them? Why 2x? Because the power 1 over 3 was in the whole thing, right? Power 1 over 3 was also on 8. There are brackets there. So the power will come on both of them, 8 separately and x separately, right? Can we cube the whole equation? How would you do that? If you cube the whole equation, you get this whole cube equals 24 whole cube. How do you simplify the left-hand side? A plus b whole cube is not the same thing as a cube plus b cube. So that's not going to help. That's going to make things complicated. Okay? So taking cube on both sides is not going to help. All right, why do I always take u and not some other letter? Because u is very rarely used in an equation already. So that's why I use u generally, because if I, for example, take y equal to x power 1 over 3 here, that will work. There's no problem with that. But the problem is, as I said, I have learned not to expect too much from all students because generally some people struggle with maths as well. So what they would end up doing would be there will be some equation in which they already have y equal to something in the question, and they remember that substitution. When we do substitution, we can take y equal to something. So they will end up using this in that same question. So we have to use a variable. We have to use a letter that is not already there in the question. So u is kind of a letter that is very rarely there already in an equation. And it's just a convention as well. It's a convention as well. Remember P3 integration substitution, when they give you a substitution, generally it's u equal to something, right? So it's a convention as well that when you use a substitution, you use u equal to something, right? But it's not necessary. You can use another letter as well, doesn't matter. Okay, that was question number 9. Let's look at the next one. Okay, let's look at the next one. The seventh term of an AP is 77. The sum of the first n terms of the progression is denoted by Sn. It's given that S11 is 880. Find the 20th term of this progression. Okay, so what information do we have? First of all, it's an AP, so make sure that you're using the correct formulas. What's the nth term formula? Tn equals a plus n minus 1 times d. Sum formula, half n into 2a plus n minus 1 times d. Input values. Seventh term is equal to 77. That's one piece of information that is given. We can use that. We can say a plus 7 minus 1, which is 6, times d is equal to 77. And sum of 11 terms is 880. So 1 over 2 into n, which is 11, into 2 times a, which is unknown, plus n minus 1, which is 11 minus 1 times the difference. That is equal to 880. Okay, now we've got two equations. We solve them simultaneously, and that's going to give us the values of a and b. Then we can just use the formula. We can use the formula, and that will give us the result. Okay, let's do this. Let's multiply 2 on the other side. And that will give us 11 into 2a, which is 22 times a, plus 10 into 11, that will be 110 times d. On the other side, you have 880 times 2, which will be 1760, right? Okay, this is another equation that we're getting. What we can do is we can make a the subject from the first equation, a equals 77 minus 60, put that in the other equation, and that gives you 22 into 77 minus 60 plus 110 times d equals 1760. Okay. Now let's solve this equation. 22 times 77. We can actually simplify this equation a bit earlier, but now that I've not done that, let's just carry on with this. 22 into 77, that's 1694, minus 22 times 6, 132 times d, plus 110 times d, that equals 1760. And that will give you a value for d. You can see what that is. Minus 22d equals 1760 minus 1694, which is going to be 66. And the value of d turns out to be -3 from that. Now that's the value of d. Put that back, and that will give you the corresponding value for a. 77 minus 6 into -3. That will be 77 plus 18, which is 95, right? That's the first term that we end up getting from this. Now that we have the first term and we have the difference, we are looking for the 20th term. T20, what would that be? A, which is 95, plus n, which is 20, minus 1 times the difference, which is -3. You can see what that turns out to be. Has anyone done this? Okay, I'll just verify that as well. 19 into -3. Yeah, so it's 38, not 28. 38. That's the one that we're getting, okay? That's the value of the 20th term. Okay, now they're saying find the smallest number of terms n such that Sn is less than 50. Now we have to solve this inequality. We already have the first term, a is equal to 95, and difference is equal to -3. They're saying Sn is less than 50. What's the sum of the first n terms formula? We already have that, right? Half n into 2 times a, which is 95, plus n minus 1 times the difference, which is -3. That is less than 50. Okay, let's simplify this. We can multiply this 2 on the other side. It's a positive number, so we can do that in inequalities. Multiply positive number on the other side. 95 into 2 is 190. 190 times n plus n squared minus n into -3, that is less than 100. Let's simplify this a bit. 190n minus 3n squared plus 3 times n minus 100, that is less than 0. Now this simplifies further to minus 3n squared plus 3n minus plus 193. N minus 100 less than 0. Multiply the whole equation by negative. It just makes it less prone to careless errors if you make the first term positive. I just like doing that. 3n squared minus 193n. plus 100. But remember, whenever you multiply an inequality with negative, the inequality sign is going to change as well. Now we've got this quadratic inequality. How do we solve quadratic inequalities? How do we solve quadratic inequalities? We need to solve them as an equation, first of all. So we solve this as an equation and see what that gives us. 3n squared minus 193n plus 100, that is equal to 0. Let's solve this equation first. We can actually do no, we cannot do factorization. I'm sorry, I don't know what I was thinking. We cannot do factorization. N equals minus into minus into minus 193. This step is necessary. If you don't show the step, you lose marks. Minus 193 whole squared minus 4 into 3 into 100 whole divided by 2 times 3. Put this whole thing on your calculator directly in the equation solving function and see what you get from that. You did not get a quadratic. You can share your working in the group and I can have a look at that. Or compare with what we're getting here, because you must get a quadratic. We have this n and we have this n. We will get n squared from that. Yeah, okay. So what are the values of n that we're getting? 63.81. Okay, 63.81. That's the first value you're getting. And n equals 0.522. Okay. Now, we were not solving the equation, we were solving inequality. So what's the solution of this inequality going to be then? It was greater than 0, right? We could do it using the curve. That will work. You can use a curve for this to find the possible solutions, or you could do it on your calculator directly as well. Okay? You can do it on your calculator directly as well. If you do it on your calculator directly, how do you do that? Menu, inequality. After this step, you can do it on your calculator, not before this. You have to show until this working at least, until this step at least. Inequality, polynomial degree 2. This is greater than 0 inequality, right? So that will be number 1, right? Okay. 3, negative 193, and 100. Now, this is what we're getting. X is, or n in this case, is less than 0.522. That's one thing that we're getting. Or n is greater than 63.81. Right, this is what we're getting. If you use a curve, that's also pretty straightforward, right? It's a U-shaped curve. It would look like this. What are the intercepts that we're getting? One intercept is 0.522 and the other intercept is 63.81. The inequality symbol is greater than 0. You've got this side here and this side here, which means we're either in this region or this region. Now, n represents number of terms. So this is not possible, right? This is not possible. It can't be less than 0.5. So we look at this. What's the smallest possible value of n? Smallest possible value of n. Greater than 63.81. What's the first value that you get? That's an integer. Smallest value of n, that is going to be 64. We are not rounding it off. We're not rounding this number off. We're saying what's the first value that we get? To the right of 63.81. Even if it was, for example, n greater than 63.1, the answer would not be 63, the answer would be 64, right? We're looking for the first number, first integer greater than 63.1. It'll still be 64. Okay, so make sure that you understand this is not rounding off. Okay, that's the value of n that we get, 64, and that's your final answer. Meetup. the condition is that the sum is less than 50. And the condition is that the sum is less than 50. Okay. It's not rounded up. It depends on the inequality, right? I'll do it. I'll show it on a number line as well for you. So the inequality, the condition was that the sum is less than 50. That's the condition. When we follow that condition, we end up getting that to satisfy that condition, n has to be greater than 63.81. 63 is not greater than 63.81. That will not satisfy that condition. You can think of it using a number line. You could say we've got a number line like this on which we have these values 62, 63, 64, 65, and so on. The number that we're getting is 63.81. That will be somewhere around here. This is 63.81. We have to be greater than that, to the right side of that. Okay. Now, what's the region that satisfies that condition on the number line? This region. What's the smallest value of n in that region? That is 64. Even if it was 63.1, 63.2, the result would still be 64. Okay. We'll have to take the bigger number. Any issues with this? Makes sense to everyone, right? Okay, let's do the last question now. Okay, so I think Khadija asked me to go back to the previous question here. This part or the other part? Okay, all right. Let's do the last one now. Question number 11, and that will complete this paper. Question number 11 from this paper now. Okay, now they're saying the diagram shows the curve with the equation y equals this and a straight line. The straight line passes through the two stationary points of the curve. Okay, so these points are stationary points from which this straight line is passing. Show that the equation of the straight line is this. Okay, now how do you find equation of any straight line? We need two things for that. Gradient and any one point on the line. Now, how can we find that? We can find the stationary points, right? We can find the stationary points. We would have 2 points on the line, then we can find the gradient as well then. Let's find the stationary points first of all for the curve. This is the curve's equation. To find the stationary points, what we can do is we can find the derivative. Put that equal to 0, minus x cubed plus 9x squared minus 15x minus 3. That's the curve. Find the derivative of this, dy over dx, and that gives us minus 3x squared plus 18x minus 15. Put the derivative equal to 0. 0 equals minus 3x squared plus 18x minus 15. All right. Now, that's a quadratic equation. We could put all the terms on the in the formula or see if factorization is possible. If I divide the whole thing by negative 3, that gives me x squared minus 6x plus 5. We can do factorization, right? X squared minus 5x minus x plus 5, that equals 0. We get two factors from this, x minus 1 into x plus 5, that is equal to 0. X is either equal to 1 or x is equal to negative 5. Now, the two stationary points are going to be at these x values. Now, what are the y values? Do not use this to find y values. Do not do that. You cannot use the information that they want you to prove. Do not put x values here. They will give you correct results, but you cannot do that. You're not allowed to do that. Okay? X minus 5, sorry. Okay, so that was x minus 5 there. Sorry, that's positive 5. Yeah. Achha, do not input in this equation, okay? Input in the original curve. When we input 1, we get minus 1 cube plus 9 into 1 squared minus 15 into 1 minus 3. And that simplifies to what? Can somebody do this calculation, please? What about the other one? Minus 5 cube plus 9 into 5 squared minus 15 into 5 minus 3. And that will give you the corresponding y coordinates. Okay, so for 1, you are getting negative 10, and for 5, you're getting 22. Okay, thank you. These are the y coordinates that we get. Now that we have 2 points, we can find the equation of the line that passes through these 2 points. One point is 1 and negative 10, and the other point is 5 and 22. Find the gradient. Gradient equals 22 minus 10 divided by 5 minus 1. 32 over 4, what's that? That is 8. That's the gradient that we're getting. Now we can write down the equation y minus y1 equals m into x minus x. When you use any of those 2 points, if I use this one, I get y minus 10, that's y plus 10 equals m, which is 8 into x minus 1. Now we need to show that it simplifies to this, 8x minus 18, y equals 8x minus 8 minus 10, and that gives us 8x minus 18. That's the equation of that line that we were looking for. Makes sense, right? That was really straightforward. Let's move on. The next part is verify that the curve also meets the tangent, not the tangent, meet that straight line when x is equal to 3. Now look at the graph. We found that this point is 1 and negative 10, and the other point is 5 and 22. The line is also meeting the curve at this particular point. Okay? We need to verify that that point is when x is equal to 3. Now, since they're saying verify, that means we can just input x in those equations directly. We do not necessarily need to solve them simultaneously and show that complete process. You cannot even do that in P1. You have to use polynomials concepts for that. That's not something that we cover in paper 1. They are asking you to verify that. You could say, you could either input x equal to 3 in both of these equations separately. That is one idea. If they give you the same y value, that means they intersect at that point. Or you could also say, this is the equation of the curve. Equation of the curve is this. Equation of the line is y equals 8x minus 18. How do we find the point of intersections? We equate both of them. So you can first equate them. Minus x cubed plus 9x squared minus 15x minus 3. That equals 8x minus 8. And now we could input x equal to 3 in this. If the left hand side and the right hand side, they are equal to each other, you could say they satisfy. Now, since they're saying verify, you need to show the step in which you are inputting values. Do not just write down that both sides are equal. You need to show the step in which you're inputting that value. Minus 3 cubed plus 9 into 3 squared minus 15 into 3 minus 3. That equals 8 into 3 minus 18. Okay. This is what we get. Now, what do we get on the left side? What do we get on the left side? Can we use discriminant greater than 0? The discriminant only is for quadratic functions, right? It's not a quadratic function. We get 6 on the left side and on the right as well. Okay. So we get 6 equal to 6, and that means the equation is satisfied. That verifies that the third point of intersection is when x is equal to 6. All right, last one. Last part of this paper, the shaded region is bounded by the curve and the straight line. Find the area of the shaded region. Okay, shaded region. It's bounded by the curve and the straight line. What's the shaded region? Shaded region is not shaded. Yeah. I think I actually processed this PDF. Let me look at the original one that I got. Maybe that has it visible. Okay, it's not really visible in the original one as well, but what they're saying is the area between the line and the curve. This is the area, but the problem is we're not sure if the other is also shaded or not. Is it just this part or this part? Okay, those of you who have any other version of the paper, do you know which one is shaded? Does anyone have any other version? Only the top part is shaded? The top part? Okay, all right. Only the top part is shaded, okay. So the shaded part is only the top part. Okay, so how do you find the shaded region? Now we know the points. That's straightforward now. This point is when x is equal to 3, right? So we know this is x equal to 3. This is x equal to 5. If we also needed the other one, we would have required to break that into two parts, because the problem is it's some part is above the x-axis, some part is below the x-axis. That's going to make things complicated. In fact, an easier way would have been to use the y-axis in that case. If they also asked you for this area, using the x-axis formula would not be uh, very straightforward in that case. It'll be very tricky. So if you did have to find this area as well, you would do something like this. Find the area between the curve and the y-axis and the line in the y-axis and subtract that, and that will work. Okay. But in this case, only the top part is shaded. Let's find this now. We could find the area between the curve and the x-axis, find the area between the line and the x-axis, and find the difference. And that will give you the result. Okay. All right. Thank you for confirming. That's the top part. Let's do that integration. I'll do that on the side here. So we have this visible area of the shaded region. The curve has equation y equal to x cube minus x cube plus 9x squared minus 15x minus 3, and the line has equation 8x minus 18. Now, one idea could be you could integrate both of them, input limits 3 to 5, and find their difference, and that will work. But since both of them have the same limits, in such problems, we can also make it slightly more efficient. Only do it if you're sure that you're doing it right. We can make it slightly more efficient by first subtracting those two functions. Find the difference of those two functions first. Minus x cubed plus 9x squared minus 15x minus 3 minus 8x minus 18. Find the difference first, and that gives you minus x cubed plus 9x squared minus 15x minus 8x, which is minus 23x, minus 3 plus 18, which is plus 15. That's what the difference turns out to be. Now you just integrate this with limits from 3 to 5, and that will give you that shaded area directly. Okay? You can do it separately as well. Only do this if you're sure that you're doing it right. Why can we do it here? Because both of them have the same limit. Sometimes you will see there will be two functions, there'll be area between them. For one function, limits will be some other numbers. For the other function, limits will be some other numbers. You cannot do this in that case, only when the limits are the same. You can first find the difference of the functions and then integrate. And that makes it slightly more efficient because you have to do less calculation now. Minus x cubed plus 9x squared minus 23x plus 15. Let's integrate it with respect to x. Minus x power 4 divided by 4 plus 9x cubed over 3 minus 23x squared over 2 plus 15x. input limits from 3 and 5. Okay, let's input those limits. Input 5, and that gives you minus 5 raised to power 4 divided by 4 plus, we can do cancellation here, that leaves us with 3. 3 into 5 raised to power 3 minus 23 over 2 into 5 squared plus 15 into 5. Subtract from this the case when you input x equal to 3, and that gives you minus 3 whole raised to power 4 divided by 4. This working is necessary. You cannot skip this, otherwise you lose marks. 3 into 3 cube minus 23 over 2 into 3 squared plus 15 into 3. Now you can write down the final answer if you want, or evaluate the first part separately, second part separately, and then you can find the difference between them. What do you get? What do you get? Anyone? 4? That's the final answer. Can somebody else confirm as well? You get a different answer? Okay, chale. As long as you've done this working right, to verify your answer at the end, don't do it the first time. Just to verify your answer, you could also input in this integration function or calculator, right? Minus x cubed plus 9x squared minus 23x plus 15. Just do it for verification by first doing your calculation manually, and then you can verify this. That's given me 4, so 4 is correct. That's the area that we get. Okay. Yeah, so we end up getting 4 from this. Recheck your calculation, and hopefully you'll find the mistake. Why are we subtracting the functions? You can do that separately as well, and that will work perfectly fine. There's no problem with that. But when we are looking for area between two functions and both of them have the same limits, it is possible to first find the difference of those two functions and then input limits directly, rather than doing them separately and then finding the difference. But as I said, if this confuses you, do not do it. Only do it if you're very sure that you're doing it right, because this is an easy question. You do not want to mess it up just trying to save a minute or two. So do it, do whatever you're more comfortable with, that you're more confident about. You can find area under the curve and area of trapezium. That's also fine. That will also work. Find their difference. That will also work. I told you what to do if they ask you for area of this part, then using the x-axis formula is not going to be helpful, because the upper part is positive, the lower part is going to turn out to be negative, and it will be very complicated. You use the y-axis formula in that case. If you had to find this green region as well, use the y limits. What are the y limits? If you input x equal to 3 there, you get 6. This is 6, and this is negative 10. You use limits from minus 10 to 6, use the y-axis formula. Find the area between the curve and the y-axis, subtract from that the area between the line and the y-axis, and that will give you that green part, if they asked you for that. Okay. What do I think about June 2026 papers, whether they're going to be easy or not? I'm not the examiner, unfortunately. There's nothing that I can say about that. Anyone who's saying anything about that is just speculating. There's no there can be no justification of saying this paper is going to be difficult or easier. But the pattern is, what they do is generally one of P1 and P3 is difficult and the other is easier. And then one of M1 and S1 is more difficult and the other is easier. That's the pattern that I feel like there is in the past papers, but we can't say for sure. Okay. All right, chale. That's it. That's it. And I'll see you again in the next class then, inshallah. All right. Allah Hafiz. Thank you. Bye.